First quiz was 2 questions long, and the other 3 were each 5 questions long. So let's take a look. Consider the code segment below. If x equals 0, then x equals -1 times x plus y. Else, x equals x plus y. Which of the following will not affect the results when the code segment is executed? Switching line 3 and 7, changing line 3 to x equals y, remove the else statement and run line 7 no matter what, or change line 3 to x equals -1 times y plus x. Which of these will not change anything?
Second one.
The second one. Why will the second one not change anything?
Because x is 0.
Because x is 0. So if x is 0, -1 times x is just going to equal 0. So we're essentially saying 0 plus y, which is the same as just saying x equals y. So changing that one to that will have no effect. A programmer wrote the following program intending to print the maximum value in list. You can assume list has at least one element in it. What change do you need to make to be able to display the correct maximum value for any list of integers? So max starts at 0 for each number in list. If number is greater than max, max equals none. At the end, we display max. So does this code work as written? Do we need to change line 6 to say num equals max? Do we need to change line 1 to say max equals list at index 1? Or change line 4 to say if num is greater than or equal to max?
Change line 1.
Change line 1. Why do we want to change line 1?
Because it only works for positive numbers.
Because it only works for positive integers. If we want it to work for any list of integers, that includes a list of negative integers. And 0 is going to be bigger than any negative integer. So we will never make a change in that case. So we want to make sure that we are comparing all of our values to other values from the list, which is why we would change line 1 to say max is equal to list at index 1. All right, quiz number 2. In the procedure mystery written below, the parameter number is a positive integer greater than 1. So we're going to repeat 4 times. Number equals number plus 1. So we're just going to add 1 4 times, which is the same as adding 4. Pretty straightforward. The program below uses a robot in a 5x5 grid of squares. The robot is represented by a triangle, which is initially in the bottom left corner of the grid facing towards the right. So there's our grid. Our robot is initially here facing that direction. So we want to find the code segment that will do the same thing as this. So let's see where this ends up. Repeat 2 times. Move forward, rotate left. So we'll go here and we'll repeat that. Move forward, and then rotate left. So our end goal is that square facing left. So let's look at where each of the subsequent values takes us. We'll move forward, rotate left 4 times, get us to that place. Now, that will get us forward, left, forward, left, forward, left, forward, left. That'll put us back where we started. So definitely not A. B, repeat 2 times, move forward. So that'll get us move forward, rotate left. We'll end up here. Also not where we were trying to get. C, repeat 2 times, move forward. Repeat 2 times, rotate left. That'll turn us backwards. So same square as B, but we're facing a different direction. Also, actually, we're going to rotate left twice. So it'll get us facing the same direction as we initially started. So say it's like I said, same square as B, still not the right one. Now by process of elimination, D must be correct. Let's just follow it through though. So repeat 2 times, move forward. So we move forward and we repeat for the second time. Then we rotate left. And then we repeat 2 times, move forward. So move forward and then move forward and we rotate left. And we end up in the same square, facing the same direction as we wanted to. So there we have it. All right, and our next question is also a robot question. So I'm going to leave my grid, erase the marking cell. So given that our robot starts in that same square, after running the following code segment, how many possible squares could the robot end up in? So x is going to equal a random number between 1 and 4. So it could equal 1, 2, 3, or 4. And y is going to equal a random number between 1 and x. So y could equal, for 1, there's only one potential value. For x equals 2, we could equal 1 or 2. When x is 3, we could equal 1, 2, or 3. And when x is 4, we can get 1, 2, 3, or 4. So x is going to determine how far to the right we move. Y is going to determine how far up we move. So when x is 1, we can only occupy this 1 square. We move 1 square right and 1 square up. If x is 2, we could move 1 square up, or we could move 2 squares up. When x is 3, we could occupy any of these 3 squares. And when x is 4, we could occupy any of these 4 squares. So if we find all of the highlighted squares, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible squares that we could inhabit after this code runs. So I will strongly encourage you, I think you will have access to scratch paper. If you have a question like this, I would very much encourage you to draw it out. It'll definitely help with that processing. All right, consider the following program, which is intended to print the sum of all the positive integers up to number. Sum starts at 0, repeat number times, sum equals sum plus number. What are we doing here? Will this correctly display the sum of all positive integers from 1 to a number? Does it not work as intended, but rather displays number squared? Doesn't work, displays factorial, or does not work as intended because sum should be initialized to 1. But the big question here is whether or not this variable number changes in my loop. Number does not change in the loop. In a repeat x number of times style of loop in this language, there is no iterator variable built in. Nothing is going to be changing. We're just going to do this thing that many times. So if number, let's say number is 3. We're going to repeat number of times, 0 plus 3, 3 plus 3, 6 plus 3. That's going to give us 9, which is 3 squared. And this pattern would hold for any other number we get, because we're going to add that number to itself that number of times. So we are going to get the number squared because we don't have anything changing throughout this code. All right, consider the following program, which is intended to print the count of even numbers between 1 and number. Count equals 0, I equals 1. Repeat number times. If I mod 2 equals 0, count equals count plus 1. Outside the if, we say I equals I plus 1. Display count. Does this correctly display the count of even numbers between 1 and number? It seems likely. I don't see any problems with this code. definitely not counting the odd numbers. We're checking if the mod by 2 is equal to 0. So definitely not checking that. We don't want to display I instead of count. I is just the number of numbers. And the program does not work because the condition of the if-net statement is to check if number mod 2 is equal to 0. That's the same problem as we would have seen in the previous question where number doesn't change each time. So this code works perfectly, works as intended, gives us what we're looking for. All right. Which of the following Boolean expressions is equal to the expression num mod 3 equals 0? Is num mod 3 does not equal 1 the same as checking if it equals 0? No, because there is another option. There's num mod 3 can equal 2. So not number 1. Num mod 3 does not equal 1, and num mod 3 and not num mod 3 equals 1. Okay. Here we're checking the same exact thing twice, so not that one. Not num mod 3 equals 1, and not num mod 3 equals 2. That seems like what we're looking for. We're checking if it is divisible by 1, negating it, checking if it's divisible by 2, or if the remainder is 1, the remainder is 2, negating it, and. If it's neither remainder of 1 nor remainder of 2, we must have a remainder of 0. And this last one is just definitely super rough. Which of the following Boolean expressions is not equivalent to the expression num times -1 greater than or equal to 10? Num less than 0 and num times -1 equals 10. Num less than -10 or num equals -10. Num times -1 is greater than 10 or num equals -10. Or not num times -1 less than 10. Which these is it? First one. Why is it the first one?
Because that only works for one case, when num is -10.
Correct. All right, so this only works when num is -10. Huh? So there we have it. Which of the following Boolean expressions is equivalent to the expression a times b is greater than 0? Is it a greater than 0 and b greater than 0, a greater than 0 or b greater than 0, a greater than 0 or b less than 0, or a greater than 0 and b greater than 0, or a less than 0 and b less than 0?
The last one,
It's
because
the last most complex one, because to get a positive product, you can multiply two positive numbers. Positive times positive is a positive value. Negative times negative is also a positive number. But if we mix and match positive and negative, we'll get a negative product. So very long and convoluted, but that is our correct answer. Which of the following expressions is equivalent to the expression A and B or C? Well, we can kind of distribute that A and across the B or C. So got A and B, or A and C. You can kind of imagine an and like a multiplication and an or as an addition. If you think of it that way, multiplying through makes a little bit more sense. We have A times B plus A times C, just like we would have if we multiplied through in actual math. And question 5, which of the following Boolean expressions is equivalent to the expression A or B and not C or D? Here we are going to use one of the rules that we learned, De Morgan's law, which lets us distribute this not across this expression. So A or B is going to stay the same, A or B. and we're going to get not C and not D. When we distribute a not across an and or an or, we get the opposite of both the operands and the operator flips. So we get not C, we get not D, and or flips to an and. And the same is true if we did a not and, we would get not C or not D. Flip the sign, and both things are negated. So we get A or B, and not C, and not D. And our final quiz was while loops. In the procedure written below, the parameter number is a positive integer greater than 1. Number, repeat until number is greater than or equal to 100. Number equals number times 100, or number times number. If number equals 100, return true, else return false. What best describes the running procedure, or the mystery procedure? The procedure returns true when the initial value of number is less than 100, and otherwise it returns false. The procedure returns true when the initial value of number is 10, and otherwise it returns false. The procedure returns true when the initial value is 100, otherwise it returns false. Or it returns true when the initial value of number is either 10 or 100, and then otherwise returns false. The answer is in fact 4. 10 times 10 is going to give us 100. And if number starts at 100, our condition will be false. We'll just kind of skip it. Now, if number is 100, we get true. So if it started as 100, or if we multiplied by itself to get 100. So option number 4 is the correct answer. In the procedure mystery written below, the parameter number is a positive integer. Result equals 1, repeat until number equals 1. Result equals result times number. Number equals number minus 1. So what best describes the result? Let's just do a little experiment. Let's plug in a number. Let's say number equals 3. We're going to repeat until number equals 1. Result starts at 1. We're going to multiply number, or result times number. So 1 times 3 equals 3. Number is going to become 2. And we're going to repeat because number is not equal to 1. We're going to multiply 3 times 2. That gives us 6. Number is going to become 1. Now number equals 1, so we stop. So will the procedure never begin if the initial value of number is 1? I feel like that's wrong because the procedure will still happen. The function will still start, even if our parameter is just 1. The return value will always be greater than the initial value of number. If it's a positive integer, if we started at 1, if number started with 1, our loop would never start. And so result would stay at 1. It would not be greater than our initial value. The return value will be a positive integer greater than or equal to the initial value of 1. That seems a little bit more correct. Greater than, definitely possible. Equal to, also possible if it was equal to 1 the first time through. So that seems like a good answer. And the return value will be a prime number greater than or equal to the initial value of number. Not necessarily. So, because here we would have returned 6, which is not prime. So we will always get a positive number bigger than or equal to our initial value of number. Our parameter number is a positive integer in this next method. Total equals 0. Repeat until number equals 0. If number mod 2 equals 0, total equals total plus number. Number equals number minus 1. So let's test this with the number 4 for our number. Total starts at 0. Repeat until number is 0. If number mod 2 is 0, which it is, total is going to add the number. So total is going to equal 4 here. Number is going to equal 3. 3 is not even, so we're not going to add it. We subtract 1, we get to 2. 2 is even, so we add it. 4 goes to 6. We subtract 1. 1 is not even, so we don't add it. We subtract 1 to 0. Number has hit 0. We are done. So is it possible that our output would ever not be even given this code? No, our code is always going to be an even value. So the return value of the procedure will always be an even number is our correct answer. All right. Once again, number is a positive integer. Value equals 0. Repeat until number equals 0. If number mod 2 equals 0, value equals value plus 1, else value equals value minus 1. Number equals number minus 1. If value is 0, return true, else return false. So let's do a couple of different numbers. Let's try 3 first, and then let's also see what happens with 4. So value starts at 0. Repeat until number is 0. Is 3 even or odd? 3 is odd, so we will subtract 1 from our value. Our value is now -1. And then we subtract 1 from our number. We get to 2. 2 is even, so we will add 1 to our value. Go back to 0. Subtract 1. And we're still not at 0, so we keep looping. We are odd again, so that becomes -1. Subtract 1. We've hit 0. Will we return true or false? Well, we'll return false because it's not equal to 0. And if we imagine how this would work with 4, value is initially going to have 1 added to it. So value is going to go to +1. Number becomes 3. We go to 0 because it's odd. We go to 2. We go to +1, down to 1. We go to 0, go to 0. So looks like anytime I have an even value, we return true. Anytime we have an odd value, we return false. So this will be true whenever the initial value of number is even. All right, and this last one is very similar in structure, except instead of adding or subtracting, we are multiplying by -1. But value starts at number. So if number starts as 3, value equals 3. And we're going to repeat until number is 0. We're going to multiply value times -1. So we have -3. Number becomes 2. We multiply times -1 again, bringing us to +3. Number becomes 1. Multiply that -1 again. We got -3. Number becomes 0. We're done. If our value is greater than 0, return true. Else we return false. So if we think about this one, it's very similar. If we have an even initial value, the return will be true again. We're going to just flip-flop until we hit 0. And if we have an odd number of things, we'll end up with a negative number. All right, any questions on any of those questions? Does all make sense? Cool. I'll stop our recording.